To determine if this table represents a direct variation equation, first of all, we need to know a direct variation equation looks like this. Y equals a number times x. And one thing I want to point out is that I'm going to actually solve for x, I'm going to solve for k. So I'm going to basically divide both sides by x, because I want to show you something. I want to show you that we can use this to help us figure out if this is a direct variation equation, or if it represents a direct variation equation. So now let's see here. We get k on this side, and we get y over x over here. And I'm going to use a symmetric property, meaning I'm going to swap sides, y over x. And we get k equals y over x. So this right here is letting us know that the constant of variation, the k, you can find it by taking y divided by x. So if I were to take y and divide it by x in each of these ordered pairs, we should get the same exact value for k in each case, if it is a direct variation equation. If they're not all the same value for k, then we know this does not represent a direct variation equation. So I'm going to go ahead now, I'm going to say, okay, so we're going to put y divided by x, just to organize the work. So I'm going to take the first one is 4 over 2. And I'm going to do the same thing for the other ones, 12 over 6. And then the last one, 24 over 8. And I'm going to simplify each one. So you could just go ahead and divide it out. But a calculator, or in this case, you can see it's pretty straightforward calculation. 4 divided by 2 is 2. 12 divided by 6 is 2. And then 24 divided by 8 is 3. So you can see that these values are not all equal to each other, because we get a different value for the last ordered pair. And since they're not all equal to each other, we know that this does not represent a direct variation equation. Therefore, we don't have to write the equation out, because if it's not a direct variation equation, we can stop at that point.